Okay, so the Bohr model. And what we're going to be focusing on practicing and representing today is making sure we do a good job and making sure we also understand that it's not the best model as well. So I'm going to write a couple things on my whiteboard here. Hopefully you guys can see this okay. Hopefully it's not too glary. I'm going to try to write as big as I can. But for the Bohr model, okay, we need to have the protons and the neutrons. You guys see that at all? You can kind of see it.
Yeah, it looks good actually.
It's behind my head a little bit. But anyways, you need to have the proton and the neutrons. Then you need to have the electrons as well. Okay. Now, for the protons and the neutrons, you do not have to draw like every single little ball. You don't have to do like 1, 2, 3, 4, 5. You don't have to do something like that. Okay. For the protons and the neutrons, you just simply need to make a nucleus, something like this, and then you simply need to write how many protons, how many neutrons you have in there. So for example, if I was going to do a carbon, I would say a carbon has 6 protons, because it's, element number 6. And then I would also say that it has 6 neutrons in here for the nucleus of carbon. Now, another way of drawing that would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is essentially the same thing there, okay? But we don't have to draw all those little itty bitty circles. Drawing all those little itty bitty circles is going to take you quite a bit of time, okay? Especially when you get to a bigger atom. So Bohr models do need to consist of the proton and the neutron, okay? And so all you have to do, draw a circle, tell me how many protons, tell me how many neutrons are inside the nucleus, and then go from there. The cool thing about the Bohr model, though, is that, it shows you where the electrons are most likely to be found on an atom. And that's the reason why we really use the Bohr model a lot in science and chemistry class, even though it's not the best model, is that it shows you where they probably are. One of the things that Bohr kind of got wrong, though, was that he thought that the electron stayed on a path. Kind of like the Earth going around the star, it stays on an orbit. Well, that's not actually what happened with electrons. Electrons are free to move. However, they are attracted to the nucleus, and they will stay within a certain area, a certain region of the atom. The other thing, too, that we have to remember is that the atom is three-dimensional in shape. It is not a flat orbit like the Earth going around the sun. Okay, the atom, the Earth could go anywhere around the sun at the same distance. Okay, whatever direction. Same thing's happening with the electron. Okay, the Earth doesn't do that with the sun, but the electron can go anywhere they want around the proton within a certain area, within a certain region. Okay, and again, Bohr kind of got that right, but not quite. But it's hard to draw a 3D model of the atom. So what we're going to do for carbon is we're going to need a periodic table, and I'd like for you guys to kind of check this out with me. Okay, so carbon is over here. Okay, and what we need to do, we need to figure out the number of valence electrons. And we've done this before. You guys have actually drawn the model kind of before with valence electrons. And so the valence electrons, if we remember, is our column numbers. So we have 1, 2, skip a few, 3, 4, 5, 6, 7, 8. 8 is the most number of valence electrons we can get, and that's called the octet rule. Okay, the octet rule is 8 being the most valence electron. Okay, to skip a few, we'll talk about that in a minute. That is a different region for the electron where they could be located. Okay, but that is an important spot. So those are called transitional metals, and we'll talk more about that in a couple of minutes. Okay, so the other thing we need to do is we need to figure out what row carbon is in. Well, the first row has 2 atoms in it, 2 elements, hydrogen and helium. The second row has 8 in there, and carbon is in the second row. So carbon is going to get 2 rings because it's in the second row. So we're going to draw 1 ring here and 1 ring there. And again, hopefully you can see that. I'm going to go different color to show my rings. Okay. Now carbon needs to have 6 electrons because it has 6 protons in it. right? So what we do for the periodic table is the first ring is going to have 2 electrons in the first ring because there's only 2 elements in the first ring. So hydrogen electron is on the first ring and helium electrons on the first ring. So on the first ring, we're going to have 2 electrons. And we do try to get them away from each other as far as we can. Now, eventually, we won't be able to get, they'll have to kind of stack up next to each other, but again, remember, it's a 3-dimensional space, and we'll talk about that in a second. Okay? All right, so the first ring only gets 2 electrons. That's it. Okay? It doesn't have any other electrons. It's a very small ring, very close to the proton and the neutron. It's not going to have a million electrons in there. It's a very small area. It's only going to get 2 electrons. The second ring, count, how many can it get? 1, 2, 3, 4, 5, 6, 7, 8. The second ring can get up to 8. And the way that we draw that, okay, and it doesn't really matter where you put them, but this is kind of how I do this, is I'll put number 1 up top, and then number 2 as far away as possible from number 1 on that ring. And then number 3, I'll put it as far away from as possible from 1 and 2. And then you kind of can guess where number 4 is going to go. Number 4 is going to go as far away from number 3 as possible. So I'm spreading the electrons out as far as I can, because remember, electrons are all negatively charged. They're going to repel each other. Okay. Now here's the problem. I can fit 8 on this ring. Where do the other ones go? They actually don't go in this area here. Okay. A lot of kids think that they don't actually don't go in that area. Number 5 is going to go next to number 1. Now again, you might be wondering, hey, Mr. Can, aren't number 5 and number 1 going to repel each other? Yeah, they don't want to be next to each other. But remember, it's a 3-dimensional space. 1 can go this way, 5 can go this way. So 1 can go that way, 5 can go this way, and they'll get away from each other. So they have opposite spins, as we call it. So one electron could be spinning clockwise, and the other electron could be spinning counterclockwise, and they won't get near each other. So we can put 2 electrons next to each other as long as they're moving in different directions. Now, if there's room, spread them out. Okay, if there's room, spread them out. If there's not room, you can double them up, as long as 1 is going up and 1 going down, 1 going right, 1 going left, 1 going counterclockwise, 1 going clockwise. As long as they're moving in opposite direction, you can put 2 electrons together. Okay, if you have to. So if 5 goes up there with the 1, 6 is going to get as far away from 5 as possible. 7 is going to get as far away from those guys as possible. And 8 is going to get as far away from those guys as possible. Okay, and then you can kind of see here that we're running out of room. And this is the reason why we have the alternate rule. We can only really fit 8 in a certain amount of area, 3-dimensionally, and have enough room to keep them away from each other. Okay, now we said that carbon has 6 electrons. We've already drawn 2 of them. So I need to draw 4 more electrons for carbon on that second ring. And so I'll do 1, 2, 3, and 4. And I am spreading them away as far as possible, okay, for this Bohr model. And then if I count them all, I get 6 electrons, which is attracted to 6 protons. So carbon has, 6 electrons. And if you notice there are 2 in the middle and there are 4 on the outside. And those 4 on the outside are called valence electrons. Now let's double check real quick. Do I have 4 valence electrons on the periodic table? 1, 2, skip a few, 3, 4. Carbon has 4 valence electrons on the outer ring, on the outer shell, on the outer orbital, whatever you want to call that. Okay? So this is what we call a Bohr model of carbon. And what we're looking for here is the protons and the neutrons. We're looking for the area in which the atoms are actually located. Okay, there are 2 on the inner ring, and there are 4 on the outer ring, 6 total. Again, this is not a great representation of the atom, and this is where Bohr was kind of wrong, is because this is a 2-dimensional, very flat drawing. We need a 3-dimensional, okay? These 2 electrons can be anywhere in that ball, okay? These 4 electrons can be anywhere inside that ball, Okay, it's a three-dimensional sphere. It's not a perfect, one-line orbital like a planet going around the star. It's a very two-dimensional plane. Atoms are three-dimensional. Okay, I'm gonna try to see if I can get some engineering kids to 3D print me some atoms that have like where electrons can be located, because it's actually kind of cool, kind of interesting. Now, if you remember though, we said to skip a few. There are other guys in here on a periodic table. When you start getting that many electrons, things start getting really interesting with the shape of the atom. So, for example, all the shapes of the atom will still add up to a sphere. You might want to draw this. Okay. So the simplest sphere you can have is a sphere itself. Okay, I'm going to add a little mark on there to make it look like a sphere. Okay, that's the simplest sphere you can get. It's just a circle, a ball. Okay. However, you can also get something that looks like this. Okay, I'm going to call that my, and it looks like a butt, right? We call that a dumbbell sphere in chemistry class. And so it is still a sphere. Okay, so again, we call that a dumbbell. Okay, so the electrons can still be in this ball shape. Okay, but we have others. We can also have what we call kind of a flower petal shape. Again, I'm gonna try to make these three-dimensional. Okay, we have a flower petal shape where the electron can be. But again, it still makes a sphere as far as shape is concerned. And so these different shapes, we actually have letters to tell you what shape they are. We have an S, a P, and then we have D, which gets really weird. D can also do other things. D can also put a donut on the inside of that. You can put a donut around there. So D gets really weird, but all of the atom shapes are still a sphere when you look at them as a whole. Okay, so let's come back over here to this drawing here and try to get there. All right. Okay, so today we are going to practice some more with Bohr drawing, Bohr models, and we're going to practice making sure that we can identify how many rings is it going to have, what row it's in. So let's write that down real quick. So rings are going to equal row number, right? Rings equal row number. We also want to know how many valence electrons is it going to have on the outer ring. Valence electrons are going to equal your column, the 1, 2, skip a few. Okay, 1, 2, skip a few, 3, 4, 5, 6, 7, 8. Again, most you're going to have an 8 on your outer ring. We want to make sure we have the protons and neutrons in our drawing, the right number of rings, and then go from there. So what I'm going to ask you guys to do today, I'm going to ask you guys to go into breakout groups. And I'm going to ask you guys together to help each other draw these Bohr models on the worksheet. So if you go to your daily schedule, or your weekly schedule, you'll see the assignment called Bohr diagrams and valence electrons, I think, something like that. Okay. I want you guys to work together and help each other out with the Bohr model. I'm going to bring you back as a big group, and I want you guys to be ready to share your results. Okay? I want you guys to be able to show me what did you draw for number 1, number 2, number 3, number 4, number 5, number 6, number 7. If I don't get any volunteers at all, I'm going to randomly call on you or somebody to share with me what they have. So in your notebook, on a piece of paper, I want you to hand draw your Bohr models, okay? And I want you guys to help each other. I want you guys to talk to each other about this, okay? All right, so do some breakout groups. Take about, I don't know. It shouldn't take you very long. Let's take about 10, 12 minutes. And then we're going to come back together and we're going to double check how you do, okay? Again, of course, as always, if you guys have questions, put them in the chat box. I can see what you write. I can see all that stuff. So you put them in the chat box, and I'll come in and see you guys and help you guys out. All right, so go find that worksheet. You're going to draw me 7 models and then you're going to answer question number 8 in your notebook, and then submit a picture of it. Okay, so again, this is what it looks like if you don't know what I'm talking about. So this is the worksheet. Once you draw 7 models together, help each other out, and then answer this question down here when you're done. So draw it in your notebook, take a picture, submit it. All right, go help each other out. If you're already done, help each other, help other kids. All right, I'm going to stop the recording because it doesn't record your breakouts.